Hi guys, thanks for tuning in, and today we're going to be introducing the camera to our rendering system. So stay tuned. When we're talking about a camera in 3D scenes, we're not actually talking about a camera at all. A camera is just two matrices that we can use to manipulate the 3D surroundings. So when we want to move our camera, we're actually moving all of our 3D objects in the opposite direction. So when the camera moves to the left, we move our objects to the right. To do this, we'll create a view matrix, which is basically the same thing as a transformation matrix, except for that the translation will be negated. Then we'll also create a projection matrix, which will help us determine how near or far objects will be rendered, as well as giving us the opportunity to manipulate the field of view of our scene. And in the future, we'll also give our camera some additional features to handle depth of field and motion blur. So starting off, we're going to create a new folder called camera, and we're going to add a index.js file here. Then we'll need to import the vec4, the vec3 and the mat4 from GL Matrix. Then we're going to go to our utils file here, and we actually need to export the to radians function. And then we can take this and we can just import that as well. Like that. And then we'll need GLC. And then we'll create a default class called camera, and we'll throw in a constructor. And inside of here we need an X, Y and a Z position of the camera. We also need a pitch variable, a yaw and a roll. So these are the rotations along the different axes basically. Then we need a near and a far plane of how far a near object should be rendered, and then also a field of view. So let's go ahead and initialize these in the constructor as well, so we can just make this happen real quick. So we're going to set all of these to 0 except for the field of view, and 0.1 for the near, and let's say 1000 for the far, and then 40 for the field of view. And then we just need to bind all of these. Near is equal to near, and this dot far is equal to far, and this dot far is equal to field of view. And now we need to create the matrices for this camera, and we're going to create two. One is called the view matrix, which is actually controlling the position of the camera, and one is called the projection matrix. So we're going to start off with a view. So create view matrix, and we can actually go into our maths file here and just copy the transformation matrix we created in a previous episode and just paste this in. And we're going to remove the scaling and set the translation here to the bottom. And then we'll just subtract all of the camera's position from this, because we want the camera to move in opposite of what our objects are. So minus this dot y and minus this dot z. Then for the Rx value, we're going to add the pitch, and then the yaw for the Y rotation, and this dot roll for the Z rotation. Then we'll create another function, and this will create a projection matrix. And first of all, we need a aspect ratio. So this is going to equal glc.gl.canvas, and we're going to take and extract the width, and we're going to divide that by the height, like that. Now we'll create a new empty array for our matrix, and then call mat4.perspective, and throw in the matrix, and then use the toRadians function and throw in the field of view here. And then we want the aspect ratio to be included. Then the near plane and the far plane, and that is basically it. And then we can also return this, so return matrix. Then we'll create a common function to generate both of these matrices in one function, so generate matrices, and we're going to say that this.view matrix is equal to this function, and this.projection matrix is equal to this function. And then we want to call these in the constructor to get them initialized. Then we need another function to be able to enable these matrices, so enable, and we're going to call throw in the shader here, and we're going to call shader.enable view projection matrices, and we're going to throw in this.view matrix and this.projection matrix. So let's go back into our shader, and we're going to create this. So where are we? There. So first of all, this.view matrix is equal to this, and then we can just copy this once more for the projection. And then we'll need the locations here. And I've already added them here, as you can see, so you can just do that. So view matrix and projection matrix. So view matrix, and we want the projection matrix. Then we need a function to enable these, so we can just copy and paste this, and we're going to call this enable view projection matrices. And just to make sure it's spelled correctly, we can go here and copy what we created in the camera, and this will take in the view and the projection. And then we can just copy and paste that, and we're going to throw in the view here and the projection here, and then we need to take these variables we just created up here, the locations. Now we need to go into our model renderer, and we're going to take in a camera here. So camera, and we're going to call camera.enable and throw in the shader. So if you remember, we made this function here. Then we need to go into our vertex shader, and inside of here we're going to use these uniform matrices we just made. So first of all, the view matrix and the projection matrix. Then we can take this, and we're actually going to multiply that by the transformation matrix, and then we're going to multiply everything with the projection matrix. So that's it for the world position. Then we'll also need to do the same thing for the normals. Now we can go ahead and go into our index file again, and we can import the camera. And then we want to initialize this, so we can do it here. So const camera is equal to a new camera, and we can just throw this in here, so inside of our model renderer.render. So now if we go ahead and open up our browser, let's see, create view matrix is not defined. All right, so let's go in here and see. Oh, of course, we need to add this before. So this.create view matrix and this.create projection matrix. And now you can see that we have a cube here, and it's really close. And the reason for that is because the Z value is actually means that we're inside of the cube. So we can set that to like 3. And there we go. So now if we can change a few settings here so you can see the difference. So if we take like 80 of the field of view, then we get a much bigger field of view here. And you can do the same thing in the opposite side, and we get a much smaller field of view. And you can play around with these. So for instance, if I change the roll to like 45 degrees, the cube is now rotated 45 degrees. And in order to show that, We can maybe turn off the rotation here, and you can see indeed the cube is rotated 45 degrees. Now the final thing we want to do is to add an event handler so we can actually move our camera around. So create a new folder called event handlers, and we're going to create a new file called mouse.js, and we need to import GLC. Now we can create a class called mouse listener. Create a constructor because we need to do some things here. So the first one is we're going to add an array, and this is going to be called on wheel listeners. This is going to be an array, and then this dot on drag listeners is also going to be an array. Whoops, like that. So then we need an init method, and inside of here we're going to define a couple of variables, so x, y, and then if we're dragging or not with our mouse, then we can call glc.gl.canvas.onWheel, give this a function, throw in the event, and then we can call this dot on wheel listeners dot for each listener and then we want to call listener dot on what is going on listener dot on wheel and throw in the event here. Then we'll need to create an on mouse down. So glc.gl.canvas.onMouseDown, and this will say that the x variable is equal to e.clientx, y is equal to e.clientY, and then dragging is equal to true. Then we also need an on mouse up, so on mouse up, like that, and then we can just say dragging is equal to false, and then we'll need a glc.gl.canvas.onMouseMove, and this will take in the event as well, and we're going to check that if we're dragging, we want to create a new const dx, and this is equal to x minus e.clientx, and the dy is equal to y minus e.clientY. And then we can say that e is equal to x is equal to this, and then y is equal to this to update it. And then we're going to call this dot drag on drag listeners for each listener, and we're going to call listener.onDrag with our dx and dy, so the difference in the positions of the dragging. And then we'll also need to add a couple of functions to subscribe to these listeners. So subscribe to drag, and we're going to throw in the listener. So this dot on drag listeners dot push the listener, and subscribe to wheel, and by the way, subscribe to me, just putting it out there. This dot on wheel listeners dot push the listener, like that, and then we'll create a new instance of this mouse listener down here. So const mouse event is equal to new mouse listener, and then we just want to export default mouse event. Now let's go into our camera file again, and we're going to import this mouse event. And all we need to do now is, in the constructor, we need to call mouse event dot subscribe to drag, and we're going to throw in this and then mouse event.subscribe to wheel, and throw in this as well, which enables us to just create a couple of functions here that will be called automatically. So on drag, and this will take in the dx and the dy, and we're going to say that this.x plus equals dx, and we need to multiply this by a factor because the dx is too, it will just move the camera too quickly otherwise, and then this.y is equal to dy times 0.01 minus, because in OpenGL the y-axis is actually inverted. And then after that we need to generate the matrices again to update the view and projection matrix. And final thing, on wheel, and then we get the event, and we're going to say that this.z plus equals to e.delta y times 0.01, and then we need to call this again. And the final thing is to go into our init file, and we need to initialize the mouse listener. So mouse event from, and we just want to call mouse event.init. So now if we go back to our browser, listener.onWheel is not a function. So let's go into our camera and see what we have done wrong. No, actually I think it's in the, yeah, I accidentally put a 9 in here, so let's do that. And now we can go ahead and try this out. So if I scroll, you can see that we can zoom out, and maybe it will look a bit better if I set the roll to 0. There we go, and then we can drag this around now, so we're moving the camera. So if you found this useful, please subscribe, and I'll see you in the next one. Thank you and bye.